As you heard from Ruth's presentation, the other two partners of the National North American Ice Service are the Canadian Ice Service and the International Ice Patrol. So the next two talks are going to be given by representatives of those two agencies. First one coming up is Mr. David Jackson, Special Project Advisor. And he used to be, in fact, the director of the Canadian Ice Service until recently. He's going to be talking on emerging needs for tactical scale ice information in the north. David?
Thank you, Pablo. Good afternoon, everybody. So this is an overview of what I'm going to talk about this afternoon. I'm going to introduce you to who we are at the Ice Service. So a lot of the stuff we do is very similar to what Commander Lane just talked to you about. I always like to give a presentation on what it's actually like in the Arctic, because I know a lot of people who study the Arctic or who are interested in the Arctic have never actually been. So it's always a good thing to kind of review those kinds of situations. Then I'm going to talk about what you actually kind of need when you go up there from a meteorological point of view, but also mainly from an ice information point of view. Then I'm going to talk about some emerging needs that we've found and been dealing with in Canada, in the Canadian Arctic Archipelago, from different operations, etc., and initiatives that we've been doing. So the Canadian Ice Service is part of the Meteorological Service of Canada. We're the leading authority for ice information and icebergs and lake ice in the country. We provide real-time and forecast ice and iceberg information to mariners. We also take care of the archive of ice information and our ice charts, as well as some satellite imagery. That's heavily used by researchers, anybody in academia, marine classification societies, oil and gas, and anybody usually working or studying in the Arctic. We also monitor Canadian navigable waters for oil spills. We use satellite imagery to direct aircraft to what we call anomalies, and then they confirm whether or not the spill is oil. And you can ask me later why that capability is resident in the Canadian Ice Service and not somewhere else. So sea ice is a very Canadian issue. We have I guess what we'll call the longest coastline and the greatest area of ice in the world. The annual variation in the extent of ice is approximately half the size of the country. And that has seasonal effects on weather and climate, marine ecosystems, safety and the efficiency of marine transportation. So sea ice development, you can see it's correlated up with the date up here, the advance and retreat. So in the Ice Service, we have two seasons, one in the Arctic during the summer, and then one in southern Canada and the Great Lakes during the winter. Those are starting to overlap due to climate change effects. Operations in the Arctic are all about safety. So there's ice up there which will damage or sink your ship. Contrast with operations in the south, it's all about efficiency, because there's no real ice that's going to severely damage or even sink your ship. It's all about moving people and goods, perishable cargo, efficiently and effectively. Arctic challenges. It's cold. There's still winter. Everybody got to remember that. So when the ice freezes in the winter, it freezes over completely to the thickness of a 4-drawer filing cabinet. I think one of the senators earlier talked about tell me in things that I understand. So 4-drawer filing cabinet thickness. That has effect on people and equipment. There's dark. There's periods of 24 hours darkness and seasons of low light. It's isolated. There's a very low population density, and there are very, very few built-up areas. There's lack of infrastructure, no real ports to speak of, repair, salvage, or fuel and provision capability. And there's vast distances. The topography is completely different from the eastern to the western Arctic. In the east, it's characterized by high mountains and very steep cliffs right down to the water's edge. So when you're talking about identifying ice on a ship's radar, it's very simple. It's very easy and very easy to see where the land begins and the ice ends. In the Western Arctic, it's all low land and low bluffs, and it's very difficult to identify where the ice and where the land changes. There are significant navigation issues. Radar is affected by meteorology. Anybody heard about super and subrefraction? You can see things sometimes 300 to 400 times the distance your radar can pick up stuff. There's satellite issues. You've got to remember that in charting, a lot of those charts, as was mentioned this morning, were charted many, many decades ago, if not centuries, and they used completely different datums than GPS. So GPS uses WGS84. So you are actually navigating with a piece of equipment that is far more accurate than the surveying that was done on that chart, and using a completely different datum than the survey that was done on that chart. So when you're navigating, you need to understand what you need to do to transfer a position, for instance, from one chart to the other. There's limited communications. Voice is okay. There are complete and sophisticated VHF, HF, MF systems, and Iridium covers up to the pole for voice. However, if you're going to translate or going to download an ice chart, for instance, that requires a lot of data, a lot of bandwidth, you're going to take 2 to 3 or 4 hours, especially when you're above 75 degrees north. Weather, there's lots of wind, lots of blizzards, increasingly freezing spray and fog. Water depth is quite variable, as you'll notice from when you look at a chart, any of the charts in the Arctic. Significant tides and currents, some of the biggest and fastest in the world. There are icebergs, and there's also ice islands and ice conditions. So anytime you encounter ice, it's always a mix of all the different ice types. It's never one. And it's always covered in snow, so it's really difficult to tell what's in that ice field. Hence, doesn't matter what ship you have, you try to stay away from it. So sea ice and ice of land origin are a danger to the safety of navigation. They're a danger to maritime interests. They impede maritime trade and commerce, and they're of interest to riparian interests. Sea ice has different stages of development. So there's new ice, gray-white, which is about the thickness of a coffee cup, for those that are remembering what that senator said. Thin, medium, and thick first-year ice, second year, multi-year. After it survives first year, it goes into second year, and after it survives a second melt, all the impurities are leached out, it becomes multi-year. Ice thickness varies. There's usually ridging and rafting. That's where the ice travels up on top of each other or collides with each other. In the Eastern Arctic, icebergs are commonly found within sea ice, and they are always accompanied by stuff that falls off them. So what are called bergy bits, about the size of a truck, and growlers, about the size of a car. The growlers are the more dangerous because you can't see them on radar sometimes if there's a sea running. Just some pictures, the nasty ridge right there. So what you see above is always paralleled by something below as well. There's some old ice in amongst other different types of ice. And here's an ice field outside Iqaluit where you've got a whole bunch of rubble, and there's an iceberg, and generally there's stuff following it and falling off it. And it's always snow covered. Another picture. Going into that even with an icebreaker is difficult. So you need weather information. You need current weather plus forecasts. That includes precipitation. Winds, speeds, direction. Ice travels with the wind, sometimes the current. It depends which is stronger. Icebergs generally travel with the current. Air temperature, whether you know that when you get out into open water, is there going to be freezing spray? And risk of structural icing. Ice information when you're approaching ice-infested waters. You need to know the limit, the edge of the known ice. How much of it is there? Is it 9/10 of what you see, or 5/10 or 2/10? The stage of development, and remember what I said, ice is never uniform, and generally it's all snow covered, so you get all different types of ice within the same ice field. And in the Arctic, you have a presence of ice of land origin, or icebergs. When do you need it? You need current conditions, you need the short-term forecasts, days and weeks, medium-range forecasts, months, and a long-term forecast, which is always based on climatology. So that's generally from season to season, so we'll project what is supposed to be happening in the next season. Ice charts are produced from a variety of sources, combination of visual observations from ships and aircraft. Satellite synthetic aperture radar is our sensor of choice because it's all weather. However, the Ice Service is also one of the largest satellite imagery users in the world. We use about 15,000 radar sat images each year, but also 60 to 70 of any type of other sensor, because when you start to combine them all, they provide invaluable data and confirmation of data. Satellite imagery provides ice information over very large areas, but it can be difficult to interpret. If you want to start transmitting it onto ships, which ships are starting to say they would like, you have bandwidth issues. So once you're starting to get into the Arctic, you have huge issues. So you try to zip it, but still, they're still too big. So you need trained ice analysts to interpret satellite data. You incorporate all of that using the international code. We have an organization called the International Ice Charting Working Group, of which all of the ice services in the world, or pretty much all of them, are members. And we seek to harmonize the presentation of ice information. So when you look at, say, a Canadian chart, or an American chart, or a Russian chart, they're generally similar with maybe some individual variances. So you need average ice concentration for areas, the percentage of each stage of development. When you see an ice chart, you will see a uniform color, and then what's called the egg code, which denominates the total amount of concentration and each of the partial concentrations of the ice. Areas of ice pressure, which is really important to know when you're going into any area, and areas of ridging and leads, especially if you're going to be walking on the ice. So what do you need for a forecast? The probability of ice being at a certain location at a given time is important to know. Possible trajectories of icebergs or significant ice flows, and the probability of ice pressure, and whether or not it's going to ease in a 12-hour period. So a lot of effort and energy goes into a lot of those types of products and a lot of that type of information. So this is a radar sat image of the western, the Beaufort Sea. So here you got Banks Island, McClure Strait, Alaska up here. And then we translate that. So generally, just by way of a bit of explanation, the whiter the reflection here, the whiter the image, the older the ice. And we translate that into that, where it tells you where the concentrations of ice are. So this is a stage of development chart. So you always look down here to see what it is. Is it a concentration chart, or is it a stage of development? So this is a stage of development, and it's all color-coded as to what's thick first year, what's thin first year, et cetera. And these are the internationally accepted, what I'll call what we call the egg codes. So it gives you total concentration, what's the next concentration of the next different types. During the winter, the Canadian Ice Service is the only ice service that monitors the Arctic. So we issue regional ice charts for that area once a week. Reason where we look at the Arctic in the winter is we need to know where all the multi-year is, because all of the old multi-year ice is generally pressed up against the edge of the Canadian archipelago, and it infiltrates during melt. So we need to know when it freezes over the winter where it's going to be at the start of the navigation season. So you need the ability to analyze and integrate all of your imagery, training in the interpretation of marine information. You need frequent updates, accurate modeling between acquisitions so that we can move that ice into a type of, into a forecast, high resolution information in critical areas, accurate, oh, I said that already, sorry, low bandwidth products for shipboard use and sometimes for community use, and additional products for onshore planning. So into emerging needs, more frequently in the last few years as on-ice operations have increased, national defense, for instance, they're using more vehicles, They're putting more things on the ice, including people. So they need to know a lot more about the ice that they're going to be going on, what kind of topography it has, how strong is it, when's it going to break up, if it's going to break up. This is a picture of Canadian Rangers on a mission patrol, and they're on sea ice, as you see, so it's very important to give them the information on where they're going to go. What are they going to have to cross? Where's the best place they're going to go? Because you start getting into some of this stuff, and ridging and rafting, it's very difficult to get your snowmobile over. And you don't really want that ice breaking up underneath you. This is the U.S. U.S. Air National Guard that participated in one of our operations in Nunavut, which is a whole of government operation in the Arctic done every year. So we worked with them to find an area to build a landing strip. So that was a very complicated operation, finding the proper ice and given the proper requirements that they needed to land that aircraft on that ice in support of the operation, because you don't want the aircraft landing 100 miles over that way when the operation's over here. So you got to find out what's going on in the immediate area and try to find a good place. Search and rescue in the Arctic can take place any time of the year, because while the Canadian Arctic freezes over completely in the winter, you are seeing some breakup in places like Barrow Strait, off Resolute, Lancaster Sound even, that incur a search and rescue when people are caught on the ice. So the challenge for Canada is it's huge. It's significant. All of the resources are in the south and operated by the Trenton Search and Rescue Region. So it takes time for that resource to come up to wherever it has to go. In fact, I'll comment on, say, oil pollution. You can have all the depots you want, and that's great that you have depots. So we have them in Hay River and Iqaluit over here, and a couple of others, plus a big one down in St. John's. And it's okay getting them up there. From Hay River, you can get to, say, Grise Fjord or Arctic Bay or wherever it is you have to get them, you land them. But frequently, that big oil pollution is not going to be around a community. Minor oil pollution is when they're being refueled by tanker. But the problem is the intermediate transportation and the ability to maintain that oil spill response or that search and rescue response. So getting it from the depot up to the community is fine, but then you got to get it from the community to where the spill is, and then you got to take the people there, and then you got to take where they're going to live and what they're going to eat, what their garbage is, et cetera, and maintain that. And a spill cleanup doesn't take 2 days. It takes a lot more. I talked about darkness. When these guys are going out for whatever it is they're going out for a search and rescue or for cultural activity or for hunting or fishing, they're going out on the ice in the dark. So they need to know with pretty good accuracy and timeliness what that type of ice condition is going to be. Arctic sea ice is a highway for many of the communities. These are just some of the well-worn, oops, what did I do? There we are. Well-worn routes that communities, Inuit, Inuvialuit, et cetera, are using. So it's used on a daily basis by those who live by and travel on the ice to and from hunting grounds, taking supplies to other communities. They need to plan their routes, hunting activities, travel activities. So we've started a program where we give much more accurate ice information on what's called the fast ice around a community. Fast in this case means it's fast to the land. It doesn't move quick. It doesn't move at all. This is a product that we started producing for Transport Canada Marine Safety. It's a reinterpretation of our ice charts based on navigability of whatever polar class you're wanting to look at. So if somebody says, well, Canadian Arctic class 4 or 3 or polar class 6, IX class 6, where can they go? So we produce a chart that's color-coded to the particular Canadian Arctic class or polar class or what have you, that tells that organization, be it National Defence or Transport Canada, where they could expect a ship of that type to be able to go. That's proven useful in many other situations for shipping companies that identify what type of class they have, where can they go, and when. Planning. This is a probability of the presence of ice chart, and you can look into it's color-coded by whether the ice is going to be around for 100% of the time or 10% of the time that you can encounter it. So you can plan quite a ways in advance when and where you're going to go and what it's going to be like, so that you can look at what type of equipment you need. This was a RadarSat-2 image that we produced for Operation Nunalivut in 2015, and you can look at rough ice and different types. According to the legend, we labeled it open water, surface roughness of heavy ice, medium ice, and light ice, and then gave them advice on where they could go and when and how that was going to move. This is also kind of the same thing, where this was a surface roughness, where you're looking at red is kind of, you don't want to go there because it's probably ridged and there's a lot of ridging and rafting, and so that allows you to, again, plan out your route on the ice. This is the community-based ice information test product that we've been using for looking at fast ice. We haven't traditionally done that before because we've only catered to commercial maritime and government maritime, mainly deep water interests, but we're now starting to find a huge demand for that because the fast ice around a community is not as predictable as it used to be. So it breaks up and does a lot of things which people don't expect. So we kind of give this every so often and update it. Red being don't go there, there's thick fast ice. So green, you can go there. As far as this one goes, we produce it on an FTP site for each of the communities. And we produce it in English and French and in Inuktitut as well. The other thing we're trying to do with this is we're incorporating as many of the Inuit classifications of ice that we can. So where we know, and this is where we rely on community observers, we have a connectivity with community observers, and we incorporate what they've seen and incorporate that with our satellite data. So we'll use whatever words they want to use on how that ice, its travelability, etc. And that's the end of my presentation. I always like to finish with a quote from Eisenhower.
That our David Eisenhower?
That's yours. That's yours. Yeah.
Thank you, David.
We had one, but I think he was the janitor in Parliament. I'm not sure.
Thank you. Time for a couple of questions. Yes, sir. Repeat the question. Sure.
So you want to know how accurate the ice, when you say, just let me clarify, what do you mean when you say ice numeral? Whether it's multi-year or gray-white or something like that?
Yeah, ice numeral.
Okay, so if I understand correctly, your question is related to the Arctic ice regime shipping system and the ice numeral generated by that. Okay, so there's two systems in Canada. There's the ship safety control zones, which specify which ships can go into which geographic area during which times of the year. So the Arctic ice regime shipping system was created not to circumvent that, but to complement that and take into account any changes that had occurred as a result of climate change, differences from the archival information for their ship safety control zones, etc. So what that numeral does, that's generated by the ship. It's generated by what's in front of you. So you look out and you say, well, this is the regime that I'm finding here, and this is I do my calculation, this is the type of ice, this is the class of my ship. This is for everybody else's benefit as well. This is the class of my ship. do I have icebreaker assistance? Yes, I do, or no, I don't. That generates a positive or a negative numeral that says, yes, I can go. So that's usually transmitted to Coast Guard and to, more importantly, Transport Canada via the NORDREG reporting system. The hole in that argument is that we then have to translate that ice information that we've produced as an ice service into, well, is that the actual ice regime in front of that ship? And the way we do ice charts, that's challenging. I don't want to say it's impossible, because when you look at any specific polygon, it may be 6/10 of ice. And the way it's presented is that 6/10 of ice is all over the whole area. But it may be up in one corner, or it may be down the other one, or it may not, maybe in the middle. So there is a disconnect between that ice numeral that the ship sees, and can we confirm that? Does that sort of answer your question? There is a disconnect, but we then rely on the ship and their ice navigator consulting the guide, which we've produced, as to what does the type of ice condition look like, and therefore what does that translate into for your numeral calculation. Long-winded, I know, sorry.
Dave, there's an online question.
Okay.
Any plans for Canada to set up a Northern Joint Rescue Coordination Center?
Not that I know of, and that's the search and rescue in Canada is the responsibility of the Department of National Defence, and the Canadian Coast Guard manages the marine rescue part of that. So I would say I don't think so. I haven't heard of any, but that doesn't mean there aren't discussions underway. There was a question over here, yeah. Well, pretty much what you've seen there, it'll depend on what kind of geographic area we want and what the satellite can produce. I mean, just because you want a high resolution imagery of something doesn't mean you're actually going to get it, because everybody's competing for satellite information. I'll give you an example. When HMS Erebus was found, National Defence and Parks Canada, they didn't give out the specific position of the place because they didn't want archaeological raiders going in and taking stuff, or looky-loos and people coming in to have a look. So the Ice Service was charged with monitoring that. So when we order satellite information, that area, we know exactly where it is, and we know the confines of the square that we want to get imagery of. So we don't just want a radar SAR-SEEN image from RadarSat. We want as high a resolution as possible that will give us as much information about the ice and about that area as possible, in as tight an image as we can get. So the issue when you're talking about high resolution, first off, is that everybody else wants probably images of the same area. If you've got the same resolution, that's no problem. You all share the image. But if somebody wants high resolution and other people want wide scan area, then you got to deconflict. So there's a whole committee for that does that. Now, as far as high resolution products, we would probably translate that into something like community information. So we would produce high resolution imagery, much higher than what we've got now, to look at exactly if we know exactly where, for instance, a hunting party is going to be going and they need information for X day, well, we'll produce a route for that. That's what we're looking at. We're not doing that right now. Probably because, I don't say probably, but because of the previous issue of ordering high resolution imagery. I can order all I want, take all the imagery I want, but whether I get it, that's going to be irrelevant. So I can't promise that we're going to get that. Does that kind of answer your question?
I think
it sort of does. Yeah. Well, you can ask me. We can talk.
Yeah, you can take it
about some of the other things that
elsewhere,
we're
please.
As well.
Thank you, David.
Take your discussion elsewhere.
Thanks.